Hi, I'm Ron Covell, and today I'm building a welding cart designed to hold both a MIG and TIG welder in a convenient compact package. It will also include space for 2 welding gas bottles and a storage tray for miscellaneous supplies. My favorite project from last year was the rolling stool with curved legs and lightning holes. It was a big hit. I plan to carry that design theme over to the welding cart. Holes are often used in aircraft and race car design to reduce weight, and when the edges of the holes are flanged, the panels can actually get stiffer. Weight isn't a major factor for a welding cart, but there's something compelling about the way negative space transforms anything. I add holes not out of necessity, but for the subtle style they bring, letting light and form play together across the surface. I started by designing the cart with a simple CAD system, taking the dimensions of the welders and gas bottles into account. If you prefer, hand drawings would work just as well. I decided on a T-shaped design, with the gas bottles placed side by side and one welder stacked above the other. Next, I chose my wheel sizes, 8-inch diameter for the rear and 3-inch casters in the front, like the ones on my stool. I'll use a solid steel bar as the axle for the rear wheels, with the base of the cart resting on this axle. This establishes the height of both the storage tray and gas bottles. The sides of the lower tray will be 4 inches tall to provide structural support for the casters. I positioned the lower welder 10 inches above the lower tray and the upper welder 20 inches above that. The cart's backbone will be made from 16-gauge steel, bent into a C shape that fits around the gas bottles. The storage tray and welder platforms will attach to this backbone, and diagonal braces will tie everything together. While these braces could be straight, I decided to curve them to match the style of the stool legs. With the overall design finished, I moved to something super important: hole layout. Getting even spacing is everything. Your eye will catch the smallest misalignments. To get the best effect, I used the largest hole sizes possible. I think that looks great. I decided to start with one of the most challenging components, the curved braces. I began by making a layout of the brace on printer paper, which I glued to chipboard for added durability. Then I transferred the design onto a piece of 16-gauge steel. Then I punched the center of each hole. Next, I cut along the edges, leaving the ends long for now. After that, I drilled the center of each hole with a 1/2-inch angular cutter, which matches the bolt size for the punch and flare dies. Now I trued up the edges of the braces on the belt sander. I tack welded 2 pieces together to speed the process. I used a flat backer on the belt for the outside curve. For the inside curve, I pivoted the belt sander to the horizontal position and used the wheel of the machine to back the belt. This allowed me to get the long edges sanded perfectly smooth. Now I'll form the edges to be welded to the braces. I'm using a heavy-duty brake to bend strips of 16-gauge steel into 1-inch by 3/16 angles. Bending a short flange like this applies a lot of spreading force on the brake, and I found it worked best to center the metal in the machine. That worked great. Using a vise to hold one end, the edges were curved to match the braces. Next, I curled the edges of the braces using a bead roller with 5/16 roundover dies. This has to be done before the holes are punched and flared, otherwise the dies would flatten out the edges of the holes. I used the same roundover dies to curl the outer side of the edges for the brace. So now this edge has nice rounded corners on both sides. Now I can tack the edges to the braces. I'm breaking in my brand new Millermatic 211 Pro on this project. I'll use the auto set feature, dialing in 24 thousandths wire and 16 gauge steel. These settings work perfectly. I'll place the tacks about an inch apart. With the joints tacked, I can finish weld them. I'm really happy with how this part turned out. I was concerned that with two long welds on one side, it might bow the part, but it actually rests very flat. Very pleased with how that turned out. The part did have a little bit of a twist to it, but that was not hard to correct. I just put a twisting force on one end, and that made it perfectly straight. So we're ready now to sand the weld smooth and punch the holes. The strategy I use for rounding a corner is to sand it to a 45-degree angle first. I sand the entire edge until I have a flat about an 1/8 inch wide. For the concave edge, I'm using a belt sander in the horizontal position so the round wheel of the machine touches the weld. Next, I tilt the table up to 22 degrees and sand another flat. This flat will be slightly less wide than the first. Finally, I tilt the table down to 68 degrees and sand the final flat. For the convex edges, I'll set the belt sander upright, and again, I'll sand the edge at 45 degrees, 22 degrees, and 68 degrees. Once I have three flats of equal width, it's very easy to sand these three facets into a uniform edge radius. To give the corners the final smoothness, I'll go over them with 120 grit abrasive on a disc grinder with a foam-backed pad. Once I've smoothed the facets left by the belt sander, I go over the surface with an orbital sander. This leaves a beautiful smooth surface. I'll just do a small section here so you can quickly see how well the process works. Using this technique, I'll sand both lower braces completely. I'm using Mittler Brothers punch and flare dies for the holes. These can be set by tightening the center bolt as I'm demonstrating here. These dies work extremely well. It's a lot faster to use the dies in a press, and since I have a nice power machine, I'll use this for the rest of the holes. My press can go to 20 tons, but I keep the pressure down to about 5 tons to keep from distorting the metal. These dies really add the finishing touch. The top brace has a rounded end, so I'll cut and form the blanks with that detail before the edges are welded on. I'll form a separate piece of metal to cap the end of this brace. I cut a section of 1 3/4 round bar, and I'll hold this in a vise to bend the cap strip around. I'll use a hammer to start smoothing the wrinkles on the edge of the flange. Now I'll place the curl back in the vise and hammer the flange against the round bar to get it flat. Now I can clamp the filler piece in place. I'll use clamping pliers to align the inner flanges. Now the joint is ready to weld. Now we'll smooth the welds by grinding. That corner smoothed up nicely. I made a full-size layout of the braces to show me where the edges need to be trimmed. I'm using a marker pen to transfer the cut lines to the metal. I'll also mark the location of the tabs which hold the welder shelves. I'm trimming the parts with the bandsaw. With some light sanding, these will be ready to weld. I'm going to weld in the brackets for the front of the welder shelves. They'll be aligned with the marks made from the layout. The lower brackets are made from a channel made from 16-gauge steel, and I need to weld a nut to the back side. I've already drilled a hole in the bracket, and I'll use a bolt to hold the nut in place. I'll hold this in a vise for welding and put tack welds on each side of the nut. I fastened a strap of metal to the bracket to hold it flush against the inside of the shelf braces as I tack weld it into place. Now I can remove the strap and finish weld the bracket. The shelf support for the upper brace will be a little bit different. One reason is I'm going to have a handle that attaches to this area here. So I want to fill in the entire end of this. So I'm doing this in a similar manner. There's a filler piece that fills the majority of the space, but I'm going to put a doubler behind it, and the purpose of this doubler is to give me a flange that will allow this part to seat tightly against the backside of the flange on the brace itself. You'll see what I mean here. This slips into place, and that flange is what gives me the good alignment in this area here. I'll use a clamp to bring this corner up. So you see we have a very nice fit with this now. So the first step is to attach this flange to the filler plate. And I'll do that by plug welding. I've drilled a couple of 5/16 holes in this, and I'll plug weld through that to hold these plates together. At the same time, I'll tack weld this nut into place that will hold the upper shelf. I'll put a clamp on this to hold everything tight. Then I can plug weld these together. Now I can fit all this together. And I'm ready to tack weld this. And now I can finish weld this joint. And now I'll grind this smooth. It's time to join the top brace to the bottom. I'll be working over my full-size layout to help with this. I made a simple fixture to help hold the parts in alignment. It's a flat bar with holes that match the shelf mounts. This bar will keep the braces aligned as they're welded together. I'll use clamps to align the edges of the metal as it's tacked together. I'll place the tacks in the open areas between the clamps. With the tacks holding the edges in alignment, I can finish weld the joint. I'll weld the backside of the flanges too. And now I'll grind the weld flat. I've got the blanks for the caster mounts cut to size and the hole centers are positioned, so we're ready to make some bends on the brake. First, I'll put in that 1/4 inch return on the top flange. Next, I'll bend the 1 inch top flange. And then, to finish it off, I'll bend the 1 inch bottom flange. The holes in this piece were done just like the ones in the curved braces, so that part was a breeze. So that will wrap it up for today, and in the next video we'll start cranking out the rest of the parts and bring them together. I'll see you then. I love making these videos and I'm honored that you're watching. Please like, subscribe, and click the bell to be notified about new videos. I read all comments and I do my best to answer all questions. If you like these videos, you can click the Patreon link and join the group of great people who help me create new videos. This helps more than you know.